talk about PyMol and Visual Studio Code. These are two of the most commonly used tools in the trade. And it's going to be, there's like a glacier's worth of depth in these tools. So this is going to be like a very bare bones overview to just kind of get you familiarized with the interfaces. And then I'm going to have a mini activity so you guys can like play around with it and get comfortable. So I'm just going to talk about everything first and then leave you guys to do the activity, and we'll walk around and help as needed. Okay, so we'll start off with PyMol. So this is a Schrodinger package, and I think you guys already have it, so we're gonna skip over this. But basically what it is it's a molecular visualization software, and it has Python under its hood. So we generally use it as like a graphic user interface, a GUI, but you can also do a Conda installation on it, as I'm showing over here. And you can create Python scripts and stuff, so you can have access to all of its capabilities in like a nicer coding format. And then it also has a little bit of an interface for like putting code directly into the GUI to make your life a little easier. And then practically what we want to use it for, so if we think about it in AI terms, let's say you've created a model and you want to see what the outputs look like, throw it into PyMol, see what's going on. It'll give you different shapes and views depending on like if your bonds are broken, if things are looking weird, if you want to color it by something and see a particular functional region, so on and so forth. It's really easy to just zoom and see what you need. And then for experimental work, obviously there's a lot of interesting stuff in there. Actually, you can look at hydrogen bond networks, polar contacts, you can mutate some stuff, do some sculpting. I don't use that as much, but it's something to look into if you're interested. Okay, so I do have access to PyMol on here, so instead of going through this, we are gonna pull it up. So, okay, so this is what the interface of PyMol looks like. I have PyMol 3.0, so if you have an older version, it's gonna look slightly different. Yeah. Okay, so this is the Python interface type thing that I was talking about. So you can use this command line. So one of the most common commands is like getting a PDB. So for that, I would do something like fetch, and then you put in the name of the PDB that you're interested in, and it pulls it up for you. And then let's say you want to clean up your PDB a little bit. I'm going to remove all the het atoms, and it just leaves me with everything that's organic.
Hey Fatima, what's a het atom?
Good question. It's basically everything. The way I think of it's everything that's not in like a protein proper, so like metal ions and like stuff like that. Water stuff floating around. That's really useful. You could do like remove water and it'll pop all of those out. You could also do that through here, like remove waters and stuff like that. So that makes it nice. But just for views, okay. So the main, I think the big ones. Can you guys see that? Okay. So here you have residues. So this is the kind of the selection toggle. So you can choose it by atomic resolution, residues, chains, molecules, just the C alpha. And so residues, if you want to do really specific stuff, if you want to do like just, you know, basic stuff like removing whole things, choosing by chains is really, really useful. And then the second thing would be Python commands, and then figures. Okay, cool. So here you can toggle that open and closed. And then this is the sequence one. So this is nice. What you can do over here is it shows you the sequence. You can select it using the sequences. So if I selected this thing, like maybe I know the sequence, I don't know where it is on the protein structure, I can go over there and I can say, okay, just grab this part for me. And then the other nice thing that it can do is, let's say I have a different one. And now this thing will show me like both of the sequences. And so let's say I have a really, really similar set of structures and I want to look at the sequences. I can align them and then look at, it does sequence alignment and structural alignment all at the same time. So that's really useful. So that's just a basic view of the interface. And there's one last thing here, and that would be, okay, two things actually. So if let's say I want to look at 1AOZ. I'm going to zoom and then I can choose what I want to zoom. So if I hide stuff like I did earlier, just clicking it on and off, then if I hit zoom visible, it'll take me to whatever's visible. if I just choose a particular length of things, then I can zoom to active selection and it'll take me into what I need to, and it'll shadow everything else out so you can look at what you need to, which is nice. And then another thing that's really nice it has is like wizards, and so here you can use that for like measurement. So in particular, you can do distances, or you can toggle to angles, dihedrals, polar neighbors, and all kinds of stuff like that. So let's say I want to see what the distance is between these two atoms over here. So I'm just going to grab one and then grab the other, and it's going to tell me it's 3.9 angstroms apart. Okay. And then there's a bunch of other useful stuff, in particular showing, because it's a visualization software. So now let's say, okay, so this is an antibody. And so these over here are going to be some of your central commands. So A stands for all, and so these are going to be really general commands. Remove waters, zoom, find, so you can find polar contacts, all pi interactions, clashes, stuff like that. S is for show, and so this is going to be how you see your protein or your ions or whatever it is that you're looking at. So right now we're in cartoon view, so we can see the beta strands and the loops and the alpha helices. If I do show as a ribbon, it's going to switch to this, where it just forms like a line through all the C alphas. If I do lines, it's basically the same. I can do mesh. This is really useful for looking at what the patches look like, because it shows like the van der Waal radii and all of that stuff. So you can see if there's like holes and stuff, and that gives an idea of like pockets. You can get an idea of packing, how good the core is packed, stuff like that. And then there's dots, spheres, there's surface. This is a little more of like an intense version of that. And then H stands for hide. So hide everything, just we'll hide everything. Let's go back to cartoon. And then if we do L, that's label. And then this is really nice. So if you are looking for, let's say you want like a particular stretch, right? So let's select the CDR H3. Oh, actually, let's go to color first. Okay, so color is like one of the most useful things on here. So you can do it by element, so you have an idea of what's going on. So in this case, you won't see anything other than C alpha, but if I do by SS, that's going to be secondary structure is SS, and so then it'll show me my beta strands, alpha helices, my loops, spectrum. Okay, so one of the really useful things is B factor. B factor is basically going to be a column at the very, very end of your PDB. And so it can store temperature information. And so temperature information will basically tell you how flexible a particular part of that structure is. And then with AlphaFold outputs and a lot of current outputs, what B factor will actually hold is the level of confidence that model has for how well they've predicted that particular structure. And so if you just put it into PyMol, put the color, you get a very quick idea of what it's really, really confident about and what the problem areas are. And then you can always just choose by any, there's a bunch of color options, and then you can also like make your own options and stuff like that. So now if we can also go in color by chain, which is really easy for finding what you need. So that's my antigen chain. This is my heavy chain. Let's select this. Let's see. So here I've done that. Now I can either, so the selection that I made, the object is here. And then I can also just use directly the sequence thing. I just double clicked it. And I can go to actions, rename selections, call it CDR, and now it's stored as an object. So this is kind of like that Python type object-oriented programming where like you can choose stuff and move them around. So now if I get another one. So here's another antibody. And so another really nice thing that PyMol can do that's really useful is alignments. So I can do that via command over here or over here. I'm going to do this for just quickness. So you go to action and then you go to align, and then you can choose what things you want to align. So if I say all to this, then I'm currently on 6XLZ, and then it's just going to align all of the other objects or full structures, not like sub objects, to that object. Only one object only, okay. Okay. Zoom in. So this, it both did the structural alignment, and then it also aligns the sequences by the stuff that's closest. And then I can color all this heavy chain. I can see, okay, put the heavy chain on the heavy chain, the light chain on the light chain, so on and so forth. On the bottom, it gives me an idea of what the alignments are. And then over here, you'll probably see that there are multiple rounds, and that's because it tries to best fit the sequence alignment and the structural alignment, and then it finds through multiple rounds how it works the best. And it's over like all of the atoms on there, so the numbers are probably going to be different from what you see when you do other tools, because other tools might just look at the main carbon of each of the residues, or just the backbone atoms, not including the hydrogens and stuff. So that's yeah, those are like the simplest behind the scenes ones. And then the last thing that you want to do is draw the figure and then put it in. And so I mentioned there's a bunch of things you can do with the colors, and there are like a ton of commands. So if you look in the Notion page right underneath the slides link for these slides, there is a little text file, and that has Python scripts inside it that have functions for creating like preset aesthetic functions. So you'll be able to recreate the same kind of figure aesthetic that like the RF diffusion paper has and stuff, which are just really nice. I like using those. And then you can mess around with those as to, whatever you want to do. So one last thing that I want to talk about, I think is just really useful for like emphasis sakes, is there's this one command called cartoon transparency that I really like. And if this is our CDR, let's say, so one of the things that you want to do the most when it comes to this stuff is like emphasize whatever part of the protein. Like no one's just going to look at the entire protein and get your point, right? Like you need to hone in and say like, this is what I want to look at. So one thing that you can do is, let's say I color everything gray, so I can emphasize using color, and I can set this to be like some super bright color, so it's really, really obvious. The other option I have is setting cartoon transparency. So I set my cartoon transparency to 0 or 1 for everything, then everything becomes transparent. And so if I set it to 0.1, let's say everything's a little bit transparent. And then what I can do is set it to no transparency for the thing that I want to emphasize. And what transparency will do,
Can you zoom in on the?
I really hope I can.
If not, that's
I think there was like a font option. Font size. Format show fonts. Okay, not off the bat I can't, unfortunately.
Can you just explain what the command, like the syntax for the command?
Yes. Okay, so it's gonna be actually let me okay. So set, and then this is the property, so cartoon transparency, and then comma. So comma separate out everything for the PyMol commands, and then I'm gonna set what the actual number is that I want, so like 0, and then another comma, and then whatever the object name is. So that's the command for the PyMol thing, okay? Okay, so now I've set the cartoon transparency of the region that I want to highlight to be 0. Everything else is 0.05, and what that does is all of the cartoons are like traced out in a bit of a color. Setting cartoon transparency takes removes that, and it also starts making the actual structure a little transparent. 0.05 will remove the tracing, but it still keeps everything else there. So depending on how you want to do that, you can move it around. And then for the final bit for drawing it, drawing fast will basically just give you a screenshot of this. And then ray slow is what's going to give you like those really nice publication worthy pictures, and then you just save image to file. It takes a little bit of time. You can see the progress bar up here, but here's an example. You guys see that? Okay, so you see what I mean? So like the cartoon transparency, you can still see everything, but it's not like highlighted. And then I just changed the color and set that transparency. It's like popping out. So it's really, really easy to see. And that way, when you're like, aligning stuff, a lot of times you want to see, okay, if 3 things are similar, there's a little bit of a change. How do you go about doing that? This is a really effective way to show that off. Okay, I think that's it for PyMol. That's kind of like the basic rundown. And then you guys can mess around with it in the mini lesson that'll be upcoming. But for now, one last thing, I guess, is that PyMol Wiki. Huge resource, all of those finicky commands, all of the, what's it called? The grammar, the syntax is going to be on there. You can copy and paste. They have examples. It's fantastic. Totally recommend. Okay, we're gonna switch on to Visual Studio Code, and I promise we'll get a chance to work with PyMol in a bit. But okay, how many of you have used Visual Studio Code? All right, most of you. Good. Have you guys done SSHing remote use through it? Okay, awesome. Good. All right. So getting started, basically, it's one of the most popular IDEs. And so one of the really nice parts about it is the extensions and all of the functionality that it has. And so you can be as simple as you want it to be, and it can be as complicated as you want it to be. And then it's got like a really, really nice interface. So let's pull it up. Okay. So just to get you a little bit, oh, I can't see the edges, can you? A little comfortable with this. Basically, this is what the central command looks like. And then you have all of these buttons up here, and this lets you choose what kind of pops out at you. And you can move these like panels around if you want and just kind of like put them wherever you'd like. Yeah, that'll let you personalize that. And then up here, you'll have the terminal, and down here you have the debug console. But the nice thing about terminal is there's all of these options up here. And so you can choose what kind of terminal usage you want to do, and you can make as many terminals as you want, and it kind of acts like browser tabs. So if I make like 3 terminals, I can toggle between them like over here, and then I can delete them as I want. On the left side, we have the Explorer. So here, once you have like a file system put into it, you can toggle between different files. You can search in your document, and then there's built-in features for GitHub control. So once you have like a GitHub repository set up, you can like toggle around with GitHub, which is really useful. This is extensions. So this is what I was talking about. Here you can download all kinds of like really, really useful functionality, some of which I'll go through later. And then Remote Explorer, and then Account. So what we'll talk about next is SSHing. So for anyone who doesn't already have SSH clients installed, I would go to extension right now. And then there's an extension called Remote SSH from Microsoft. So if you install that, that'll take like 2 seconds. And the nice thing about these extensions is they generally come with like really nicely written documentation. So if you have any trouble, you can always just go back and refer to that. Okay. Once you have the SSH client involved, you'll see this little button on the bottom left side, at least for me. I don't know if it's the same for everyone. I think it should be, but it's gonna look like this. Hold on. It looks like that. Click that. And then at the very top center of your Windows, you should get a pop-up, and then it's going to ask for your SSH login, which is usually going to be in the form of like your email ID at, and then whatever like the host is. So once you put that in and enter it, it'll tell you if there's any additional extensions or whatever, like Python and stuff that you need for your SSH client. But it'll walk you through it and let you install it. And then in the slides, I have more links for tutorials if you guys need that. Any questions? Okay. And then one thing I did want to show you guys, so I'm going to SSH and show you what it looks like. So once I hit the SSH, I get a bunch of options. You can go into GitHub, you can go into a remote repository. I'm going to go, and then it saves whatever you want in your bash RC file. Well, great. All right. Okay, so now I'm into my SSH server. And then I go in using my terminal over here. So the easiest way to pop all of your files into the VSCode interface is to do code and then the name of your file. Or the other way to do it is like if you, actually, if that works. And then I'm gonna do a Jupyter notebook. This is a Jupyter notebook that I have, and then I also have a Python file. Okay, so the nice thing with this is if you see at the very, very top, I have like basically my file path laid out. If I grab this, then I can go between different Python files in here. And then if I have my Git repository attached, then I can put it in here. I haven't updated it, but all of my stuff would pop up over here. For Jupyter notebooks, okay, who here is familiar with Jupyter notebooks? Fantastic. Who here loves Jupyter notebooks? All of those hands should be up. All right. So Jupyter notebooks are most useful, I think, for Scratch and for plotting. And the biggest thing is when you work on computer clusters and AI, these huge data sets, you need to get plots for like really, really big pieces of data. You don't want to cart all of that data into your local desktop. It's gonna just blow everything up. So this is a great interface for that because you can use a bunch of different plotting packages that you're familiar with in Python and stuff, and just plot all of that data on the spot. And it's super quick. You can use interactive nodes, like you can optimize the heck out of the whole situation. And then what's really nice about for VS Code and Jupyter Notebooks, this saved my life, you can make outlines using the markdown cells. So these markdown cells are basically where you can put text. And now if you put a hashtag in front of it, it makes it into like an HTML tag, basically. And it also gives you like, you know, title, subheading, heading, that whole thing. So the number of hashtags, the smaller the tag gets, but then I can toggle around and jump around. So my, like a whole experiment can be in here. But just by putting the markdown, one, it gives me really, really good organization. Two, it propels me to comment and make sure all of my stuff is really readable, which is fantastic. And then I can always, what I like to do personally, my workflow is that I will put Scratch in my Jupyter notebook. And then once I have the code running, working over there, comment it all out, copy and paste it into a Python file, make a note of where that code now is in what Python file, run it. And I know exactly where all of my code is. And then obviously it should also go into GitHub and then, you know, be nice and clean. But that's one thing. And the second thing here, oh, you know what? It's not doing the function thing. It was doing it the other day. I don't know what's going on. That didn't work. I don't know. Okay, so the other thing you can do is like if you have a file full of like classes and functions, stuff like that, usually if you grab this, it'll give you a list of all the functions in here. And then if you're familiar with like the GitHub website where you can like click on a function, it'll take you to where it is in the file. You can do that kind of stuff here, which is fun. And then I think the final thing that I have for VS Code, but yeah, I think that's like the bulk of it. And then I will say that Tmux is super useful and Protein Viewer as well. Okay, so how many of you know about Tmux? Yeah. Okay, so Tmux is basically usually when you're working on terminal or like VS Code or anything like that, you're working on it, you shut off your laptop and like you lose everything, right? You either have to leave it open and running, and then like if your computer times out, you're screwed. So Tmux lets you disengage all of your background processes in a terminal, and so keep everything running. You can close your laptop, you can do whatever you want to do, SSH from a different client and come back in, and it'll still be going. You don't have to worry about things shutting off in the meantime. So I've put a link for Tmux in here as well, so you can mess around with that. And then the very final thing is going to be Protein Viewer. So again, you're going to have a ton of PDB files and stuff like that in your computer cluster because they take up a ton of space. You don't want them on your local desktop, and carting them to your local desktop every single time can be a bit of a pain. And so some wonderful people came up with Protein Viewer, which is actually the same background that works in PDB website when you do the structural viewer. And so it's basically all like the same commands over there, but you can pull it up remotely. So if I go up here and I say show and run commands, and then I hit Protein Viewer. So this is an extension. You can just go in and get that set up over here by Arian Jamasib. And then also for the Jupyter notebooks and stuff, you're going to have that installed on your SSH client. But yeah, you guys can go ahead and do that later. But so Protein Viewer is going to be over here. And then once I've done this, I can, there we go. Okay, so if I hit that, it will bring in whatever I need to. And then you can mess around with the 3D representation, apply action. So you could do transparency, you can color it by different things. This is really nice because you can do it by residue properties and stuff like that too. So secondary structure, residue name, hydrophobicity is really, really nice. Yeah, so there's a ton of functionality and you don't have to move all of your proteins around. You can do everything remotely, which is fantastic.
Sorry, how do you use that again?
Oh,
You
yeah.
open the PDB and then you.
So you go show and run commands, and then you do start Protein Viewer. So once you have it in there, you can put that in, and then you can enter a PDB over here. And then once you have your SSH and everything up, if you have the PDBs in your folder, once you set that up, you can just grab a PDB over there and see whatever local PDB you have in there as well.
So can you open the PDB file on VSCode?
Yeah.
And it will open up as Protein Viewer?
Yeah. I don't use Protein Viewer that much, so.
Yeah, so you can.
Oh, you can,
I think the biggest thing is you have to have your Explorer set up to a specific folder. And within that folder, you have your PDB files. If you click on it, you'll just see the text, you'll just open the file as a PDB, which you'll see, the columns and the rows of all your atoms. But if you right click it and then hit View in Protein Viewer, it'll open up as a new tab with the Protein Viewer, and you can just rotate it and mess around with it.
Okay, cool, there we go. Okay, so here I added the folder in, and then I said go here, and then this is my PDB file, and then I just double clicked on it, and it launched Protein Viewer from file, boom. You got it, yeah. And then you have everything. All right. That's that, and then that was it. And there's like a couple of other extension and PyMol stuff inside this.